So welcome again, electrician, aspiring electricians. So today I'm just continuing with formulas. At the started off yesterday with single phase, smaller, the simpler formulas. But now I'm stepping it up a notch. So this one now, just want to forget the electricians going for level 3, level 4, and engineers, young engineers, right? In colleges, those who looking to enter, those who just graduate and so forth. So I'm going to talk about, so let's explain some simple, some basic 3-phase formulas that all electricians must get themselves, acquainted with. Because going forward, if you want to, you're going to take the exam and you practice efficiently. These calculations will be a part of the exam, and a lot of them, the code refer to them a lot of time, especially when it comes to 3-phase motor, whether it is motors, transformers, or generators, right? So these formulas are very critical, and you need to get them, know them. All right, so as I said, we have a 3-phase calculation, right? And in our industry, electrical industry, we deal with 3-phase. So it's either, and the 3-phase can be either delta or star, right? So if it's a delta, right, a delta would be like this, right? And this is our star system, or Y, right? This is our star system, right? So normally, if I go here, I can just put in some the winding here. Right. My delta, instead of my delta, I'll put in another winding. Alright, put in my winding again. So right here. It's my winding. Alright. And you have it A, B, C. So this now is my Y. My Y have a star. I can also have my winding here too. I can also have my winding here. And also have my winding here. Alright. So let's label it. So this is delta. That marker not going anywhere. This is from away from there B. Delta. And this is the Y R star. So there it is, right? So 3-phase. So when there's a motor can be connected delta, put A there, and can be connected Y or star. The same with transformer generator, right? So these are the two main winding, right? A delta winding and a star winding. So Y or star, delta winding, right? So I'm just going to explain these right. So this no. So in a 3-phase system, right? Phase current, right? Phase current. IP is phase current. IL is line current. VL is line voltage, right? VP is phase voltage, right? So in star, right? Star here, we have star here. As I said, only one current. So in this system, right? Says only one current flows through us in a star system, right? Says whether it's between phase, whether it's a line or phase, one current in a star system. There it is, one current. So let's go through and interpret our formulas here going down. So here we are at IP phase current equal line current because we deal with star. However, in a star system, the phase voltage would equal line voltage, right, divided by root 3 And the value of the square root of 3 is 1.732. And all young electricians supposed to know that. They must have that in their head, right? Going down, we have our line voltage equal, right? Line voltage equal phase voltage times the square root of 3 in order to get your phase voltage. You get your line voltage, and you are dealing with a star, right? So where power is concerned, it will be now root 3 times line voltage times line current, right? Where the current is concerned now, right, it would be the power, right, over square root of 3, which is 1.732, times the line voltage. Did you try to get that? A circuit with power factor. So we have circuits with power factor. What we're going to have there now is power equal, right, root 3, which is 1.732, times the line voltage, times the line current, times the cosine of the angle, right? So this is now a circuit with power factor. So you have to put in the cosine of the angle here. There's a symbol here, right? Where the line current is concerned, here we have IL, line current is concerned, and we want to find, we have the power. So we just do our necessary transposition, and we have the power on top there. We have root 3 here, which is 1.732, again, times the line voltage times the cosine of the angle, which is the power factor, right? So that is it. So simple. So this is the star. This is the star system, which is this. Right. So we just explain this, right? So we're going over here now. We're going to go now to delta. So in a delta system, delta configuration, a delta system there is now which is this. Here we have our delta now with our 3 windings here, right? And they are closed there. So our 3 windings. So whether it's this is a motor generator, right, or transformer, they are connected in this type of configuration, right? So it's a delta system. So a delta system now, right? We have one voltage here, right? So see 1 voltage. So line voltage equal to phase voltage. So any two phases, right? The same voltage exists where delta is concerned, the delta configuration, right? So come here, we have the phase current. However, phase current equal line current divided by the square root of 3, right? Line current now is going to equal now the phase current times the square root of 3, which is 1.732, right? Phase power now in this case, so we're talking about delta now. Power now is going to equal now to square root of 3, 1.732, times the line voltage times the line current, right? Via line voltage IL, line current. Circuits with power factor, right? And power factor, so therefore now we are circuit power factor now. What we do, we find power now. Want to find power, we have the root 3 here, square root of 3, 1.732, times the line voltage times the line current times the power factor cosine of the angle, right? So this is a circuit now, with the circuit now, the power factor in the circuit, right? Line current now, so we want to find the line current now. I say again now, we can do our transposition again. And we have to do the control, we have the power here on top, right? Divided now by the square root of 3, which was 1.732, times the line voltage, times the cosine of the angle, to find out that, right? So this is when you have a power factor now, and they apply the formula, the 3-phase formula, right? And I remember now, I see you have now power factor now. So what is power factor? Power factor is really the ratio between true power and apparent power, right? True power is actually the power that you actually use, consume, right? Apparent power is a power that you are supposed to get, but you don't get it, right? Because normally in a AC system, AC system with windings, you know, there are always going to be losses, right? So you're going to have losses because of the heat, you know, generating, you know, from the winding and so forth, right? And you know, and these losses now it's just a part of it. So you have you normally, I say generators, they normally rate generators and transformers in kVA, because you don't actually get that true, you know, the actual power from it, right? There's losses in the winding and so forth. So true power over apparent power. And true power is measured in what? Kilowatts, right? And apparent power is measured in volts, amps, VA, and it could be VA or kVA. And if it's kVA, it will be the thousands of kVA, right? Thousands of volts amp. Kilowatts, thousands of kilowatts, right? So remember now, there's some constants and some numbers there that normally when you're doing some of these three-phase calculation, you might have to plug them in the equation to get the answer, because they are constants. If you don't put them in the equation right now, you won't get the correct answer. So things like electricians out there now, and youngsters now put this in their head with maths concerned, because I want as much youngsters get started master maths. Right, I'm not good at it. I'm just confess, I'm not a maths person, but anyway, for what it is, right, maths, remember the square root of 3. The square root of 3 is 1.732. That's a constant, you have to use it as something. So let's say we have a formula now, so that suggests that you have to use them. Square root of 2 is 1.414, right? Pi is another thing we have to use. Normally when we're doing AC three-phase calculation, it's a must, so we have to use this pi, this constant, and this constant is 3.141, right? So pi, this is what pi is, the value of pi, and it's a constant that you have to put in the equation when you're doing the calculation. So youngsters get that in your mind now, and remember now, I want a lot of those youngsters on the street wiping car glass and things like that, you know, young men out there, you know, not finding it, you know, making good thing of their life, right? Be a man, step up to the plate, right? Get something in your head, follow, right? You know, take whatever opportunity, because, you know, eventually I said, if you are disciplined enough and you decide to buckle down and train them for, you know, the possibilities there, you know, a lot of you can eventually go to the United States. So, United States they want you, because, you know, they're going to have close to them. The language is the language speak the same language like them. Right, and you know, they know Jamaicans are noted for the, you know, the work that they have done all over the world. Especially because I've seen a lot of Jamaicans been going away on the farmer program. So I think in case the farmer program follow, because nothing no last forever, nothing not certain, we know you can fall on the trade. So whether it's electrical, plumbing, right, HVAC technician, welding, pipe fitters, right, those persons, because there's things going to be on this platform, and what I'm doing here, especially with maths, English, and other things, general knowledge, concerns can make it a rounded individual that they can apply and move on, you know, and go on to make to make something of yourself. So until next time, this is what it is for three-phase calculation in star and delta system, right? So electricians out there, get familiar with them and apply them. So when you start to take the exam, you know, they have the calculation, the calculation, you know, to apply the formula, do your transposition, your manipulation, and get the correct answer. So that's it for this video. Thank you.